Hey guys, the objective for this video is we're going to be solving two equations with two unknowns. We're going to be doing it four different ways. We're going to be using matrix algebra, Cramer's rule, Gauss elimination, and then Gauss elimination in matrix form. So here's our problem. We have 2x1 minus 5x2 equals 1, 3x1 plus 5x2 equals 14. So this is just a introductory video. That should be, a lot of this should be a revision to you, but we'll just quickly go through it. So let's do matrix algebra first. So the first thing we need to do is write this in matrix form. So matrix form looks like this. We take all the constants, or I should say coefficients, so 2, minus 5, 3, and 5. We take the variables, x1 and x2 like this, such that if we were to multiply this row by this column, we would get back to that matrix, to that equation there. And this row by that column would get us back to that equation there, equals just the values. Okay? So I'm sure you remember how to matrix multiply. You just take the row by the column, the row by the column. So, for example, 2 times x1 minus 5 times x2 would get us back there. 3 times x1 times plus 5 times x2 would get us back there. So that's just putting this equation in matrix form. We can call this the A matrix, this x, and this b. Now to solve, we want to find x1 and x2. We need to get x equaling A inverse b. So the way I got that was I multiplied both sides of this equation. So we have ax equals b. I multiplied both sides by A inverse, and for matrix algebra, it's important which side you put the things on. I need to put A inverse on the left there, which means I need to put A inverse on the left there. It would be incorrect to put A inverse there, and then A inverse there. If I put it on the left in this equation, it needs to be on the left in that equation. From matrix algebra, A inverse times A is just the identity matrix. So this is Ix equals B. And the identity matrix is essentially just 1 in matrix algebra. So this is just x equals, sorry, there needs to be an inverse there. X equals A inverse B. So that is what we're going to have to solve. We're going to have to find the inverse of A. So the moment we have this situation here, Ax equals B, we're going to have to find inverse of A. So just a reminder of how we do inverses. If we had a matrix A which equaled A, B, C, D, for example, for a 2 by 2 matrix, the inverse is equal to 1 on the determinant, and the determinant is A times D minus B times C. So that's the determinant of A. Outside of, you swap the A's and D's around, so that becomes D and A, and pop a minus sign out front of B and C. So that would be the formula for the inverse of A for a 2 by 2 matrix. So in our case, let's go find the inverse of A. A in our case equaled 2 minus 5, 3, 5, which means that the inverse of A would equal 1 on 2 by 5 minus 5 by 3. Outside of swapping these two values, we would have 5, 2, and putting a minus sign outside of these values would be 5 and minus 3. So that's the A inverse components. We know that x equals A inverse B. So I'm just going to write x, which is x1, x2, equals A inverse, and B is 114. So 114. So there I have x equaling A inverse B. Now if we were to solve this, we would have x1, x2 equaling, the solution to this is 25, and this is outside of 5. So we'd have to multiply this row by this column. So 5 by 1 is 5 plus 5 by 14. So 5 by 14 is 70. This one here would be minus 3 by 1, so minus 3, plus 2 by 14, so minus 3 by 1, plus 2 by 14, which is 28. So this essentially is 1 on 25. Outside of 5 plus 20 is 25. 5 plus 70 is 75. 75, and 28 minus 3 is 25. So if we were to find this, 75 on 25 is 3, and 25 on 25 is 1. So there we have x1 and x2 solved by using matrix algebra. The next thing we're going to be looking at is Kramer's rule. So number 2 is Kramer's rule. So I'm going to rewrite our equation in matrix form. So 2 minus 5, 3, 5, x1, x2 equals 1, 14. So that's 1 and 14. Excuse that line. Okay, so Kramer's rule is simple. All you need to do is first find the determinant. So we're going to find the determinant of A, which we actually found in the previous video, the previous section. So this determinant is 2 by 5 minus 5 by 3. If you were to solve this, you would get 25. Now, Kramer's rule is very simple. All you do is to find x1, you take the determinant of this matrix, but you replace this column by 1 and 14. So you're going to find the determinant of 1, 14, replacing this with this and leaving minus 5 and 5 there. Sorry, I keep writing on 5, that's just 5. So minus 5, 5, on top of the determinant of A, which we found to be 25. So if we were to solve this, we would have 1 by 5. Once again, we're finding a determinant for the top here. Minus 5 by 14 on top of 25. And if you were to find that, you would have 75 on 25, which equals 3. For x2, you now replace the other column. So we're going to leave 2 and 3 there. So it's the determinant of 2, 3, replacing this column, minus 5, 5, with 1, 14. On top of the determinant of A, which is 25. So solving for x2, finding this determinant, we'd find 2 by 14 minus 1 by 3 on top of 25. And if you were to solve this, you would have 25 on 25, which equals 1. Okay, which is the exact same as our previous answer. x1 equals 3, x2 equals 1, x1 equals 3, x2 equals 1. Okay guys, I'm gonna continue with the other two methods in the next video, so we'll see you there. Hope that helped, guys.